Hey, how's it going? So today I'm going to show you how a motor starter works. This is just a square D NEMA 00 motor starter. Just go over some of the basics of it, kind of explain what it does and how it does it. I take the cover off here. See, there's all kinds of description here, some wiring schematics showing you how to wire everything up. And if you look at that, you can figure out exactly all the things that I'm about to tell you. But I'll explain how some of these components work, what it is they actually do and whatnot. So first off, at the top, you have power coming in, the L1, L2, and L3. And then at the bottom, you have the T1, T2, T3. That is the leads that goes out to the motor. In between, we have the actual coil right here. We have the solder pots. That's the overload protection. This is the reset for the overload. And then up top here, see where it says terminals 3 and 2? You actually get some terminals right there, 3 and 2. That's an auxiliary contact that's built in with the starter. That gets used as the holding contact for the start-stop station so that this can be energized. So first thing, if I take my meter and I set it for continuity, so first thing, if I go from L1 to T1, I have no continuity, right? And let me try to put that in there, right there. This little divot right here, this little arm, this is how you can force the contactor. I wouldn't do this if this was energized, but this kind of helps prove the point of what happens. So when this coil gets energized, these two terminals that go to the coil, this is a 120 volt coil. So if 120 volts gets applied to these two terminals, that energizes the coil and it causes it to turn into a magnet and suck in. Ha! Wouldn't you know? There's something wrong with this one. Well, that's all right. We'll figure it out. Let's see. Let's try T1, T2, and T3. Let's see what happens. Yeah, we're not getting something completed. Well, we're going to figure that out. Normally, when you force this, it would cause the circuit to be complete. Let's see what the holding contacts do. Let's try that. Let's see. Nope. Huh. Well, let's find out. So, I take these screws out. All right, cover comes right off. This is the actual coil itself. 120 volt coil. Once again, if I apply 120 volts to these two terminals, all that's in here is just a mess of windings. All right, it's really thin wire wrapped around a few 100,000 times maybe. What happens is, this is the armature. This is in there all the time. And then this piece right here is sitting in here. And when it's de-energized, there's a slight gap. When this coil gets energized, it turns this into an electromagnet that causes this to click together like that, okay? Notice this little hook right here? That hook integrates into a little lever right here in this motor starter. That hook fits right in there. So when that coil gets energized and it turns into a magnet, it sucks in just like that, right? Now, if I dig down another layer in this motor starter, if I take these screws out, okay, so this is the lever that drops down whenever that coil gets energized. So what happens is, if this is de-energized, when that coil gets energized, turns into a magnet, it drops these contacts down right here. These are the contacts for each phase that complete the connection between these phases, right? So this is called a double break connection, right? Because this bar right here is making the connection between these two contact points, right? And then this right here, this is actually our auxiliary contact. If I can get it to slide out, that's all this is. So for some reason, I don't know why that wasn't making we go. There we go. So yeah, so the auxiliary contact is making, and this is how you can test this stuff too, right? This pops right out. It just fits in that slide right there. It's got a groove, a special, it's specially formed so that it only fits in one way in one certain position, right? And that fits in there. And then when that coil gets energized, it drops down, it sucks in, and then it pulls that little brown lever down. It pushes it down, and that's what actually makes and breaks the auxiliary contact right there, okay? So then, let's see. Power comes in, gets completed across these three phases when these three drop down. Then power comes up here, and it goes to the solder pots, okay? This is the overload protection from the motor. This was actually protects the motor from burning up, right? So there's two connections right down here, these two terminals. Let me get my screwdriver to point. You got this terminal and this terminal, all right? That's just a contact, okay? It's a normally open contact, really, but it's constantly held closed by these solder pots, okay? It's always denoted on schematics as a normally closed contact, because it usually is. But I guess when you get right down to the nitty-gritty of it, it's a normally open contact that is normally held, mechanically held closed, so latched closed. So if I take my continuity tester and check this, geez, I'm not getting anything across any of this. Oh, there we go. I had to reset it. So right now, that is a closed contact, right? So what we would do is, if we had 120 volts for our control circuit, we would have the neutral go through, land on one of these terminals, and then come out the other terminal, and then terminate on one of these terminals here on the coil. And the purpose for that is if the motor gets running too hot, it starts pulling too many amps or whatever, because it's, you know, I don't know, whatever, it's getting old, maybe whatever machinery it's driving is not getting lubed, you got some bad bearings, whatever it is, the motor's working harder than it should be, so it's pulling more amps than it should be. These solder pots right here, they're designed so that they literally, there's a little gear right here that's holding this latch closed. That little gear is being held in place by a little bit of solder in there. If that solder melts, then it allows that gear to spin. And when that gear spins, if you look at this one, I'll hit it, it flicks up like that. When that happens, that breaks the continuity of our overload contacts, our overload relay, right? So you would lose the neutral connection for your coil, for your motor control circuit, and then that would de-energize the motor, thereby protecting the motor and shutting it down before it burns up. This red handle right here is the reset button. You just press it, and that resets it, right? So right now the contact is being held closed by these gears, right? And then let's say the motor, once again, is pulling too much power, and the ampacity that's flowing through these overload solder pots gets too hot, and it melts the solder. Boom. It opens that up, and it de-energizes the motor just by opening up the control circuit, the 120 volt control circuit. And it's really any of these. It could be any phase. Any one of these opens up, and it will de-energize that contact. Okay. Guess I didn't really find out why it wasn't making that connection across here, but I don't know, maybe I'll do another video on that, kind of troubleshooting this. But yeah, that's just, you know, that is basic magnetic motor starters. Just a real quick overview of what the components are, what they do. I just want to hit on that real quick. One thing I will mention too, because I've seen a lot of people like checking overloads on these, you know, maintenance electricians or people that just don't know any better. And not to knock anybody, but I just want to mention this real quick. You know, they'll go to check overloads and they'll check continuity across the overload. They'll be like, oh yeah, I have continuity across these. Okay, they must be good. Well, that's not really the right way to check these, right? Because if these get hot, it doesn't matter. Like, this will trip, and you'll have no continuity across your overload contact. Like, this could be tripped, but you're still going to get continuity across the physical overloads themselves, right? It's not continuity across these that you're really necessarily worried about. It's whether or not they've melted enough to trip that mechanical overload, that mechanical latch, right? Now, that being said, I mean, if you have a solder pot and you don't have continuity across it, like, there's obviously something wrong with it, right? With these types specifically, and that has to be addressed too. But I wanted to hit on that. Like I said, I've seen electricians testing overloads that way, and it's just, that's not the best way to, that's not the most complete way to verify operation. But yeah, that's all it is. It's crazy. Just some movable contacts and an electromagnet configured in the right way. And that's really what makes this whole thing work. So that's all I got. Hope you guys enjoyed it. Yeah, talk to you later.